Hi guys, Azur here. Welcome to another tutorial. This week we're looking at the BookWorm Pavilion by Nudes Architects. This one is quite complicated, lends itself very well to some kind of computational design like Rhino and Grasshopper. Okay, so I know this tutorial is a little bit long, but I guarantee if you stick along with me, you're going to learn a lot of things. All right, so if it's your first time here, make sure you go ahead and subscribe if you want more Rhino and Grasshopper tutorials headed your way. And don't forget to download the tutorial files as well so you can follow along with any of our videos using the link in the description box below. And let's get right to it. All right, guys, as with any project, first it helps to kind of examine exactly what we're trying to do. So when I look at this project, it's got this interesting undulating kind of shape. You see it has this like spine in the middle, and then it has the library books that are coming off these ladders on the side. So let's have some more views of this here. You can see sometimes they're tall and you can pass through them, and sometimes they have shelves on them. Of course, we're not going to get to that level of detail in this particular tutorial. We're just trying to get the overall form and the gestural idea of the project. And let's see how we would be able to do that. So clearly you can see at some points it's narrow, some points it's wider, it's taller, shorter, and it has these shelves in between. And another interesting thing you'll notice, especially from here, is notice how it's always doubled, right? It's almost like this is one ladder, and you can see that these two pieces are pretty much identical, and then you have another ladder and so on. So basically it's almost like we're creating a normal looking ladder and then stacking them next to other ladders, each one shifting just slightly either in height or in width, and that's kind of what creates this overall form. Okay, so let's go ahead. Now that we kind of have an idea of how this works, let's see if we can actually model it. So here in the Rhino file, if you download it, you'll see that I've given you 3 of these curves already in here. So 2 of them you can see are on the ground. They're going to determine our width. And so of course I've referenced them in Grasshopper so that I can always change this as needed. And we'll test it out as the script develops. And then I also have this curve up here, which is kind of my spline curve. I noticed I've written spine. Yeah, spline. Yeah, I think it's fine. It is like a spine. All right. So we'll keep that up there. We'll keep these here. Let's open Grasshopper, and you'll see in your file, I've already referenced them in here. So let's make this a little bit smaller just so we can kind of see what's going on here. In fact, I might do that. All right, now how do we actually start building this project, right? What would I do to these curves? Well, when I look at them, my first guess is maybe I should divide them, and first notice that they're all 3 separate kind of curves over here. Maybe that's not what we want. Maybe I should merge them together. Okay, and as I'm merging them, my gut is telling me I should actually use entwine. And if you're not sure what the difference is, let me show you right now. So entwine, and let me do the same thing with these 3. And primarily, entwine and merge are pretty much the same thing except for how the data is organized. So when you merge, what happens is, especially if they're just individual elements like this, what's going to happen is that it will put all 3 elements into a single list. And notice that this list actually has just this branch number here, 0. So in branch 0, you have items 0, 1, and 2, which are the 3 curves, right? Contrast that with entwine, and what entwine does is the exact same thing, except it's almost like it's grafted it. So if you're not familiar with graft or any of that, don't worry. We'll cover some of that here, hopefully, if it comes up. But essentially what it does is it takes each element, or each input rather. So each input could have, you could feed whatever you want into here. And what it'll do is it'll place all of that under one branch, and then place all of this under a second branch and a third branch. So here I just have 1 item, but you could have as many items as you want. And that's essentially the difference. So just so you know what the difference is, again, if we need to use this, we'll come back and just change it. But for now, I'm going to delete the merge and just stick with entwine. Again, so this is entwine. All right, so that's what I've used here. And let me go ahead and use, like, say, divide curve. Divide curve, that's what my gut's telling me. Let's divide these curves. And you'll see, oh, here they are. Where'd they go for a second? This is how that works. Now, the only problem with this is I don't think the curves will line up. Like, I don't think these points will line up because, of course, this is at a different length. This is at a different length. This is at a different length. So let me check in another view. Let's say we go to the front view. And if I zoom in over here, yeah, already on the bottom, you can see that these 2 are not lined up. So this is not going to work. We want to be able to create those ladder legs, which are going to be straight up and down, and they need to be vertical, right? So if you use divide curve, that's probably not going to work. So I'm going to try another one. I'm going to try contour instead. Okay, so let's just try this first one, contour, and the curve. We know the curves, which is these curves over here. So let's feed those into contour. And just so we don't confuse this output with a divide curve, I'm going to delete the divide curve. Okay. And now it's asking for a point, a start point. You'll notice there's already a point in there, which is the origin. Let's leave that alone. And the direction here, the direction is the Z direction, which is kind of weird. Because I'm not contouring this way. Like if I was contouring a skyscraper, I would contour in the Z direction because the skyscraper goes up. This thing is going here, like from left to right. So it's going in the X direction, which is always the red line. So actually the direction, I'm going to replace that with X. Okay, and the component's still not working. So probably means I need to input this thing. And here it says the distance is empty. All right, now what is the distance? If I come back here and just kind of have a look, it looks like maybe about 2 feet or so. Yeah, that might work. So 2 feet. Again, I'm working in feet. So let's say 2.5. I'll just make a slider called 2.5 and enter that in here. And you'll see that this is what it does. It starts to contour them. And of course, this is parametric. So actually, just for argument's sake, let's start a little bit wider at say 5 feet. And we will call this the ladder width. Okay, width, and the units are feet. So we'll call it that. That way we know exactly what this slider is. And now let's look at this in the front view. And now if you look in the front view, you'll notice that both those points are coincident, right? And directly above them, and I know if I draw like a vertical line, for example, you'll see that oh, that's kind of weird. It's slightly off, maybe just because the zoom level, but it should be directly above it over here. Okay, so all these points should line up perfectly. And we'll know more once we create those lines in between them and have a look over there. So let's go ahead and try that. Let's start connecting these lines together. So under contour, you'll see that points come out, and let me put in a polyline component because that's what most people do. Like, all right, let's connect these points with a polyline, and it doesn't work. Now, why doesn't it work? Anytime this happens, you want to make sure you're looking at the data, okay? So let's go ahead and look at this data and see what's happening. Notice that in here, look at how it is. Like 0, 0, 0 is where the branches start, and it ends at 2, 2, 19, and each of them only have one item each. A polyline component can't just use one item each, so that's going to have a really hard time. What you need to do is go down a branch level. Okay, so you want to go down and trim this tree by one level. So if you type in trim tree, okay, and actually let me do that over here so you can see all the components. And I have my own component here, LC trim tree, where you can download it from that link below. This is, the trim I always use just to avoid confusion for myself. And you'll notice that it changes from this type of language where you just have each branch having its own item to this type of language when you trim the tree down, where you in this branch now, instead of just having one item, it has all the way to 20 items, and then another branch which has 20 items, and a third branch which has 20 items. And you can guess what that is. That's each of these curves, essentially one set of points, another set of points, and a third set of points. Right? That's how it's divided now. So this, if I put into the polyline component, actually makes the same line again. It just kind of joins that line back, right? That's not what we want. What we want is that kind of A-frame kind of shape coming over here. So you don't want the list going this way, right? Up and down. You kind of want the list going sideways. So anytime you want to flip the direction of a list, like this, where you have 3 branches, for example, and I have 3 branches with 20 items. Instead, I want 20 branches with 3 items. Anytime you want to do that, you want to use flip matrix. So flip matrix will change the direction of the rows and columns, so to speak. And actually, why am I putting the polyline in there? I need to change this data, which was the curves, which we first trimmed. Then we put it in here. And if you're getting lost on this a little bit, that's okay. I understand. Okay, so don't worry about all those technicalities. For now, just follow along. Okay, and you can always come back. And as you learn more about list management, more and more of these little steps will start making sense to you. Also, just want to let you know that if you're new to Rhino and Grasshopper and want the most effective way to start learning, take my free intro course at onehourgrasshopper.com. I'll teach you step by step the right way to learn Grasshopper and how you can avoid common mistakes that most users make. I'll give you my personal Grasshopper template to keep you organized and my custom components that have helped me and thousands of others be more productive. I'll also give you a list of my favorite Grasshopper plugins. So if you want to start learning Grasshopper the right way, head over to onehourgrasshopper.com now and begin your computational design journey today. Let's get back to the tutorial. So sometimes when this happens, it's because of the tree structure, like you see 0, 0, 1, 1, 2, 2, and that should work, but the problem is it's like double branch level, which is really annoying. So in cases like that, and I know this may get a little bit too advanced, but nonetheless, I just want to show you some of these components because sometimes people just don't even use these because they don't know when to use them. So here, for example, is a perfect time to use the path mapper, okay, which just kind of renumbers these lists so it's easier for some of the other components to read. So sometimes when you have lists like this that the numbers just don't make sense, like it shouldn't say 0, 0, 1, 1, 2, 2. It should say 0, 0, 0, 1, 0, 2. Okay, that's how this component will work. And again, if you didn't know that, that's okay. That's just things you'll learn along the way. So anyway, I'll place this in here and I will right click on it and say create renumber mapping. Okay, so that'll renumber them. So now if I look at the output, you'll start to see now it's just 0, 1, and 2. And that should work in the flip matrix. There we go. So now the flip matrix works properly. And now instead of having 3 branches with 20 items each, I now have 20 branches with 3 items each, which I then feed into the polyline component. And ta-da, I have now created, let me zoom out here. So again, we still only have a few components, even though we've been spending some time on the list part of it. You'll notice that we have almost what we need. Look what's happening. Instead of giving the A-frame, it's actually going from the bottom to then the top or something like that. So that's probably got to do with this order right here. Notice that the top spline is the first branch coming in. So that's where the curve is starting. Then it's going here, then it's going here. Instead, what we want to do is probably start here and then go up and down, right? That'd be easier. So maybe I'll start on the left, then the spline comes in the middle, and then the right's on the side. So there we go. Now it's kind of fixed and we're already approaching that design. Let's look at this from the front view and you'll notice, look at that. Now they're all perfectly vertical, right? And if I change the width, it should adjust accordingly. All right, excellent. Okay, so far so good. All right, now what's the next step? Well, let's go ahead and start putting that structure in. Notice that the ladders, so to speak, we'll call them ladders for now. The ladders on the side, they have these beams that are holding up the members and the shelves, right? So let's go ahead and start constructing those. Now, there's a couple of ways to do that, but I'm going to use a method that I generally use to add profiles onto curves like this, okay? And that's by creating the profile on the end and then sweeping it all the way through. So how do we do that? Well, first let's find our curves, right? So we will call this, actually, instead of just saying polyline, I'm going to create a new curve component over here, just so I can label it, and that way I won't get confused. So I create a new curve component, right click on it, and then CRV, and I will call this ladder rail, okay? This just helps me remember exactly what this is so that when you're looking at your definition, you're not just seeing data and vertices and polyline. They're actually things related to your project. All right, so now that I have the rail, what I want to do is start drawing, for example, a rectangle, like a profile, a rectangular profile, because this is a plank of wood, so I know it's a rectangular profile on one end. Now, how do I get to one end first? And how do I start drawing on a plane at that end? The easiest way to do that is to create a perpendicular frame. So if I just start typing the word perpendicular, perp, you'll start to see that perp frame is right here, okay? So the way this component works, perp frame, is you give it a curve and then you give it a parameter. So let me give it a random parameter like 0.25 or something, okay? Give it that parameter, and what it does is it will find a plane on the curve at that parameter. Now, when you're using parameters like this, almost always what you want to do is reparameterize your input curve. Okay, so you want to always right click. Anytime you have a component, this is just a general rule of thumb that will help you out. If you see a component and parameter or the letter T or something is one of the inputs, always right click on the curve and hit reparameterize. It'll make your life a lot easier. And what that does is it tells you that the beginning of the curve is always 0 and the end of the curve is always 1, which means the middle of the curve should be, around 0.5. And you can see that's kind of where we are on top. We want to be on one of the ends. So either you go all the way to 0 or you go all the way to 1. I'm going to stick at 0. And actually, I wouldn't use a slider for this. If you're going to if you know you'd need the number 0 and you're not going to be sliding it around, just use the number 0. So double click, use a double quotations, and then hit 0. And this way you're not tempted to slide this back and forth. So here we are. Each one of these curves, now we have a frame at the beginning. If this frame looks too big or too small, you can always come up here under display, go down to preview plane size and change the size. So for example, in my file, it's 5, but if it was 50, for example, it might look really large and ridiculous like this. So if that's happening on your computer, just go ahead and change that to something more reasonable. I'll change it to 3 actually, and now you see it's much more comfortable on my eyes. It's still the same plane, it's just how it's previewed on your screen. Now let's go ahead and add a profile over there. So what kind of profile did we discuss? We said we wanted a rectangle. So I'll just double click and open up a new rectangle. Where do I want this rectangle? I want it on this frame. And it has drawn a rectangle. It's quite big. If I hide the frame, you'll actually see the rectangle better. So let me click the frame, Control Q to hide, and now you see all those rectangles. Now this is quite big. Okay, definitely it's not going to be this big. Where is this size coming from? Hover over X size and you'll see it goes from -1 to 1, which is -1 to 1 feet. So that's 2 feet wide. That's really wide. And on the Y, it says -2 to 2, which is actually 4 feet wide, right? So that's really big. We definitely don't want it to be this big. So let's write down some dimensions of what we think this beam is going to be. So let me come back to the images. They don't look any more than say 4 or 5 inches tall, right? And the thickness is probably just about 1 inch or so. So let's just start with those numbers, 1 inch wide and 5 inches tall. Let's try that. So again, I will just create something like this, like 5, right? And you can label this if you want, and you can say beam height in inches, okay? Beam height in inches, 5, and I can say beam thickness in inches is 1. All right, so beam height and beam thickness. Can I just plug these right in here? You can try, and what will happen is this one will now go 0 to 5, and again, it's 5 feet. So just because I wrote inches doesn't mean Grasshopper is going to convert it to inches. I have to convert it to inches. So to convert inches to feet, which is my Rhino model, what I'm going to do is just what should I do? Divide, right? Yeah, you would divide by 12, right? Divide by 12. So all I did was double click, divide by 12, and hit enter, okay? And you'll notice this B, if I hover over it, it says 12. So that's a good shortcut to use. The problem with this is you don't actually know it's 12 unless you hover your mouse over it. So I always like to right click and then click here in this and say equals 12, something like that. Okay, that way I know it's dividing this by 12. Now if I plug this in, okay, 12 is 0.41 feet, and now this goes 0 to 0.41 feet, which kind of works, but notice what happens is it'll create the rectangle on one side of the line. I want it to be centered, so in order to be centered, what I need is half of that value on the negative side and then half on the positive side. Okay, now I would have to do some math to do that, so I actually have another component to help me with that. So if you type in domain and you've downloaded my components, you'll see here that you have a split domain, which is really useful. So what I'll do is just enter a number in here and it will split it for me. Let me show you what it does. So you see I entered a 0.41 and it splits it to a negative 0.2 to a positive 0.2. So you don't have to worry about the math. The math is all done in here, and that just makes my life a lot easier. I can plug this into here and I'm done. So I'm going to repeat that for the next one. And let's see, plug this into here. So 1 divided by 12 gives me 0.0833. That splits in half, and that goes here. And you'll notice what it looks like. Actually doesn't look too good in my opinion. One, because it's going the wrong direction. So instead of being this wide, that should actually be the height, and the thickness should be this side. So I should actually just flip the X and the Y. So this one's going to X, it should go into Y, and this one should now go into the X. And that looks a lot better. Okay, but the dimension's a little too tiny. So maybe it's the scale of the model, and that's okay. We can always adjust it. So instead of being 5 tall, we'll say 12 tall. And instead of being 1 inch thick, we'll say 2 inches thick. You know, and again, you can always change this as needed, right? But once you have the profile, once you have this rectangle, all that's left is then to sweep that form along this curve. So we will come over here, rectangle, I have the rectangle. We will type in sweep. You have a sweep 1. Perfect. So the section is the rectangle, and the rail is where is this section traveling? That is the ladder rail, wherever it went. There it is. So let's go ahead and have a look at that. So the ladder rail, let me actually just bring it over here so we know exactly what we're looking at. And ta-da, there we go. Okay, you can actually make this thicker or thinner as needed. Okay, so again, I can take this and double it if I want to. 24, right? I can come here and increase the thickness here if I want to. You can make all those changes here as needed. The thing is though, even though this is working and it's working quite well, it's only creating only one side of that rectangle. If I go back to the photographs, you'll notice that I actually need them as doubles, right? So each one that I create, I actually need to copy it over to make its double. So let's go ahead and see how to do that. So what I'm going to do is take each one and then kind of move it along, right? So I'll take, for example, this first one here and move it to the left in the X direction, okay? So it sits next to this one. In fact, I don't even like looking at it this way. Let me use my BREP preview. And it's going to make everything look a lot better. So plug this in, and I can hide some of this other geometry here. So again, I'm going to take this first one and move it. So all of them, all of these BREPs essentially, and again, you can relabel these as needed just to make sure your definition always stays more organized. So I can say this BREP is like ladder leg 01, and then I'll have a ladder leg 02. So that's ladder leg 01. And to get ladder leg 02, I need to move the legs, which is the sweep, in which direction? In the X direction. So motion is towards the X. And by how much? Well, it's the, what is the distance between these two? It's the contour distance, right? We have that. Yeah, the ladder width. We have this distance here. So instead of dragging this all the way over, what I can do is create a new number and just put this in the number, and then it'll make it a lot easier for me to drag that and kind of move it where I need to. And you'll notice it works, but the problem is there's an overlap, right? Because it's literally overlapping with the next one. So I need to move it that much and then move it back just a little bit. Now, how much? I move it back by the actually by the thickness of the ladder, right? So the thickness of the ladder is right here, beam thickness, which is 2 inches, which in feet is right here, 0.1667, right? So it's actually this number minus this number. So it's the full distance here minus the thickness. So that thickness is right here. So full distance minus the thickness gives me this number. Let's try it out. Let's see if this works. So that goes under the X. And yeah, that seems to work. Let me go to my top view and you'll see exactly what I'm talking about. So you see each one, this one got moved. Actually, it starts on the other side. Yeah. So this one got moved over and then scooted back, and now they all sit right next to each other. Okay, let's go ahead and color that one in as well. So that will be my ladder leg 02. And I can either make it a different color or just use it this way. So I have ladder leg 01, ladder leg 02, and there we go. Now that's starting to look a lot better. Okay. If I go under, it's kind of giving that same language that we had from before. You see? So they're all kind of doubled up now. That's looking much, much better over here. Okay, so now I can actually start putting those shelves in, right? That's really the last step we have to do. Notice also there's a couple of small things like, this is kind of hovering over the ground a little bit from this point. Technically, it would go under a bit and you trim it. I mean, there's all these little things you'd have to do. But in this short YouTube tutorial, I'm just going to show you the basic setup. Okay, so let's go ahead and add some of those shelves. Let's see, where are we now? So in order to add those shelves, I probably need to use the rail, right? Because these things are doing great and they're their own thing. So I'm just going to hide those, knowing that they are working, and start drawing the shelves using these curves here. So one way I'm going to do it is if I take that rail right here, let me copy that rail over actually. So I'm going to copy the rail over somewhere separately. So I'm just looking at the rail. And I know that the shelf kind of goes, the shelf goes in between two of these curves. Okay, so it goes in between ladder leg 1 and ladder leg 2. So for argument's sake, what we'll do is we'll actually split this up and start working on just one side. And then if you guys want, you can practice on the other side. All right, so I am going to explode this curve. Okay, the ladder rail, I will explode it. And what that will do is give me a bunch of ladder segments. Okay, so there's 2 segments. If I hover over this, you'll see each list has 2 items, which you can imagine what those 2 items are, the left side and the right side. I only want one of them. So to pick out an item, I'm going to use list item. And that's the list. And the first item in that list is this left side. At least relative to my view, that's the one on the left. So I'm going to hide the ones on the right. Let's see, where would I do that? Right here. I can hide this, hide this. There's so many things we can start hiding now that we have our primary geometries in. We can really start cleaning up our definition just to make sure that we're only looking at the portions that we need to work on. Okay, so here we have those legs, so to speak, just one of the legs, I understand. Okay, now what can we do next? Now, this is a point where you can start to decide, okay, how many shelves do I want, right? Do I want the shelves to vary depending on the height? So when it goes really low, maybe it has fewer shelves. When it's really high, maybe it has higher shelves. That's completely up to you. There are a couple of ways to do that, but for the sake of this tutorial, I'm just going to use divide. Okay, divide curve, straight up divide curve, and just choose like the number of shelves this way. Okay, so for example, if I put in the number 4, it would divide this into 4 segments, and I could probably input a shelf here, here, and here. Okay, so I probably wouldn't put a shelf all the way on the bottom and all the way on the top. I would just keep the shelves kind of in the middle for now, for this tutorial. So in order to do that, I don't need these points on top and I don't need the points at the bottom. First, let's see how the list is organized. So if I hover over points under divide, you'll notice that each curve got divided, right? And you can see n equals 5. So each curve got divided into 5 points. Now I don't need 5 points. I only need like the middle 3. So I need to remove the first item and the last item. So when you need to do that, there's a component I like to use that I created called trim ends. Where is it? Trim ends. There we go. Trim ends. LC trim ends. And you can take the points, put it under data, and what it'll do is remove the first and the last item. Now, you can't really tell here because this thing is still visible. So I will select the divide curve and hide it, showing only these 3. And you see that you're only dealing with these curves right here. So notice that I entered a number 4 and it ended up with 3 shelves. Okay. Now, wouldn't it be nice if this slider was number of shelves? That would be cool, right? But it doesn't really work now because this is 4 and that is 3. So in this case, what I like to do is just mess with the input here, right? Either add or subtract a 1 in order to make this work. So let me try here. So when it goes into count, before it counts this as a number 4, I have a gut feeling that if I increase the number to say 5, like if this was read as a 5, I would actually get 4 shelves, right? So when this is a 4, basically the component should read it as a 5. So you add an expression in here. So right click on count, go to expression, and type in x plus 1. Okay, so this tells the component, hey, I know a 4 is coming in, but before you treat it as a 4, add 1 to it and treat it as a 5. So now actually this slider, which is 4, actually controls the number of shelves, which is pretty cool because now I can have more shelves or less shelves, and I can actually choose the number that I want. Now in the exact same way that we did before, we're going to draw a profile of the shelf, and then instead of using sweep, we're going to extrude in this case. So again, I have these points, and I'm going to create a rectangle on those points. Now, look at that. Already, I start to see that there's a problem when I just take the rectangle component and plug the points in there. Notice that it draws by default in like the XY plane. Now, that could work. I could technically draw the rectangle sideways like this. Let's just like the way it is, draw it flat, almost like I'm drawing the top of the shelf and extrude it down. But in my particular case, what I want to do is draw it from the side and extrude it along the x-axis like this. So drawing from the side, I first need that plane. And if you look down here, that plane is the YZ plane. Okay, so you can type in YZ. Okay, and then that is essentially going to be the origin. Oh, sorry, that's going to be the plane on which we draw this rectangle. So these points are now the origin. So I'm drawing a little XY plane on each of those locations and then plugging that under plane. And there we go. Now I have my rectangles. Of course, they're not the right size, and that's perfectly okay because guess what? I can always use some of the information I used earlier, right? If I come back up here, you notice like you have beam height, beam thickness, dividing them by 12, and then using those into the rectangle. I can do the same thing. So I'm just going to copy all of this, copy and paste, Control C, Control V, and just drag them down here. Except it's going to be a little bit different, right? Instead of beam height, this may be shelf width. And someone's on a leaf blower outside. I'm not sure if you hear that, but if you do, I do apologize. So here's shelf width. Oh, sorry, I actually typed it in the wrong place. So that comes here. And we can make the width really anything we want. So the width actually is more like a depth. So I'm going to say maybe 15 inches right here to hold the books. And that is going to be depth because the width is really determined by the ladder, right? That's not a number we would enter. Anyway, that's the shelf depth, and maybe the shelf thickness, again, can be 2. And we can see what that looks like. So this will be shelf thickness. And again, you plug this into here and just try just plugging it in directly and seeing what happens. And then you can see if you need to edit it or not. And already just plugging it in the X and Y seems to be the right orientation for it. It starts to create that little profile. I can always change these numbers and it will change this profile. I don't even have to keep it as a panel. I could change it to a slider, so I can always slide it up and down and change it live. Okay, but now the only thing that's left to do with the shelves is to extrude it. So you can now extrude these rectangles. In which direction? This way, where my mouse is. So in the red direction, which is X. And now again, the classic question is by how much? Because they're just going to go by default, maybe 1 foot or so. And we may realize that we need to do it by how much? Ta-da, the ladder width. Again, you can just use a number component. You know, sometimes when you have a slider so far away from where you need to plug it in, it just makes sense to add a component like this, which you can then just zoom out and drag to where you need it and use it over there. And you can see here we have all of our shelves. Okay, let's actually color our shelves in. So again, I'm going to use my BREP preview component. Just makes it easier to see things. I might give it a different color just so it distinguishes itself from the surrounding a little bit. So give it a little orange color. And let's turn on the legs and let's give it a nice rendered kind of look. And let's see how this project is going. Okay, there's so much more we can do with this. We could notice how the shelves actually go from center to center. We could make it so that the shelves go perfectly from one edge to the other edge through some move commands, similar to what we did earlier with the creating the second leg of the ladder. Okay, we can change the number of shelves according to the height. There's so much we can do over here. Okay, so let's see if the slider works. So number of shelves is 4. If I slide this up, I should actually have more or less shelves. Perfect. Let's see if our control points kind of work. So if I, for example, use F10 to get my control points and I really bring this up, yep, everything works over there. If I want to stretch this out, I use a control point. Let's see, let's find a control point here and let's drag this out. Yep, that seems to work. So everything is fully parametric. It seems to be working just fine. And I'm going to end this tutorial here. I'd encourage you guys, if you want to try on the other side to get the other leg. If you come over here, notice your ladder rail that you first exploded. You have two segments that come out, and we picked the first one, and that's what we started to use. So I'm actually going to create a curve component here to make sure that I know what I'm using here. This is the curve. This is the ladder leg side 1, and then you can probably get ladder leg side 2 just by doing this. So what you do is you come under a list item component like this and use the little plus icon, and this is basically the next item in that list. And so the next item is the ladder leg side 2. All right. So I hope that has helped. If you like this tutorial, give it a thumbs up, subscribe. And of course, if you have any requests, let me know. I take requests for all kinds of projects. So if there's something super challenging you see out there and you're wondering, how do we make this in Rhino or Grasshopper or Revit or any kind of program like that, just go ahead, put a comment in this video down below and let me know. Take care and stay safe.